Hey, Bogdan Mrzyski here. Welcome to another video on quadratic functions where we're going to go over quadratic functions in vertex form. So let's go. My little, screen right here. So oftentimes you may see presented equation of a quadratic function in that form, where you identify leading coefficient, and then you have a binomial to the power of 2 plus a constant value. So if you remember transformations of quadratic functions, that may look familiar. If you're first time here, so this is the leading coefficient not equal to 0, never. And x minus the value of h represents the shift of that quadratic function to the right. If it's x plus value, will be to the left. And then this is the vertical shift up or down, depending whether you're adding or subtracting. So that sort of transforms the location of the vertex from 0, 0 to new coordinates h and k. So that's the vertex which is extracted directly from that vertex form, hence the name of parabolic function in that form. And coefficient 8 determines the direction of the opening and whether the parabola is narrow or maybe wide. All right. So let's look at the example right here, where we have equation of a parabolic function or quadratic function in that form. So what we can identify here, that the coefficient a is 2, h is equal to 3, and k value is equal to 1. So in this sort of picture here, you can see what each coefficient does to the equation. And when you use Desmos, which is highly recommended, you can confirm finding on the graph. So what do we see directly from the graph, or the equation rather? Coordinates of the vertex, the direction of the opening. You don't see x-intercepts. They may not be any x-intercepts altogether, but you may always see the vertex and direction of the opening. If you were to find a y-coordinate, you would have to put 0 for x and then do the calculation. So vertex form pretty much gives you the location of the vertex, then axis of symmetry, because this is very closely related. X coordinates points to the location of axis of symmetry. If my x coordinates of the vertex is 3, I know that the equation of the axis of symmetry is x is equal to 3, or a nicer standard form of a line of equation, x minus 3 is equal to 0. We don't know other things immediately, but we can find by solving this equation when you choose to say let this be equal to 0. So that would be the statement that allows you to find any x-intercepts if possible. Now, from this graph, you see there's no x-intercept. And that would be revealed by solving the equation, where you would get a square root of a negative number, no answer in the set of real numbers. Okay, so this example number 2. A is negative, so that gives you the direction of the opening of parabola, right? X plus 3 raised to the power of 2 minus 4. So x plus 3 tells you that the value of h is negative 3, because negative 3 minus from the formula would convert into plus 3. So the parabola was shifted 3 units to the left. The opening is down, and then there's a drop by 4 units down. So this is the information that we can extract from that formula. We don't know if there are x-intercepts, and you can predict that there will not be x-intercept when your vertex is below x-axis and you're pointing down. So this is, you start observing like there is a a lot of information indirectly provided in that form. The axis of symmetry coincide with the x-intercept, not x-intercept, x-coordinates of the vertex, so it is at -3. So hence you see the line right here splitting the parabola into two equal parts. The y-intercept, if you choose to find, you put 0 for x, you do the calculation, and you get -22. The vertex is the maximum value of the function, where the maximum value occurs at -3 for x. And how much is the maximum value of the function? It is -4. So this is the highest point on the parabola. The y-intercept, we already discussed that. X is equal to 0, y is equal to -22. Calculations. And now x-intercept, you understand by observing the graph, or you can attempt the calculation by setting this equation equal to 0. So those are the things that you can grab from vertex form. Now, the next example has a value as a fraction, which can be a real number that is not equal to 0. So any other number except for 0 can be used for the leading coefficient. So this is x minus 4 minus 9. So the coordinates of the vertex, according to the vertex formula, is 4, positive 4, and -9. Hence, you have this location of the graph. And the axis of symmetry also is at positive 4. So it lines up with the x-coordinates of the vertex, splits the graph in two equal parts at x is equal to -4. And then, because of the location of the vertex, direction of the opening, we have x-intercepts. And those x-intercepts can be found by letting y is equal to 0. And we already did video on solving quadratic equations. But in case you have forgotten, you would put 0 for y, and then rearrange, isolate for x. And then in this case, the square root from the numbers that you would get would be either -1 point something something or +9 point and a decimal version of that. So when adding x-intercept together and divide by 2, you guarantee to get +4 because you know where the vertex lies, and you understand that the average of x-intercepts gives you the location of the vertex. The form of the equation already gives you the coordinates of the vertex, but you see the connection. And the y-intercept is always calculated by putting 0 for x into the equation. So that's always the method, regardless of the form of the equation. An axis of symmetry is either given by this equation, x is equal to a constant value, or x minus the number would be equal to 0 if you choose to show it using the standard form of equation of a line. So hopefully this makes sense now, how beneficial or what is the sort of advantage of having quadratic function in factored form, vertex form. Apologize for that. It gives us the location of the vertex, gives us the direction of the opening, and axis of symmetry immediately is obtained from the equation. So that's it for this video. Before we go anywhere, practice, remember, implement your knowledge, your skills by doing questions. Share this video and watch other videos on consolidation, all those forms together. See you next time.